All right, do you need more time? Are we good with this one? All right. If this is on the AP test, which I have seen an exact question like this 2 or 3 times, and it's really nice, you do not have to be super technical on your graph, on like your things. So it says it has an initial energy of 20, so I'd put a line right there and call it 20. All right? An activation energy of 15, so I'd put a line up here and call it 35. And I would come up to that line, and then I'd come down. And then it says an energy change of 6, so I'd put a number down here and call it 14. And I would come down and just have it flatten out at 14. Yeah, the energy change is from where you start to where you end, not from here. You okay with that? Okay, that is literally all you would have to do. If it's endo, yeah, endo, it would go here. Okay, now down here, draw and label it for endo. So give that a shot for a second. So endo, we know it's going to go up and it's going to end higher, right? All right, initial is 25. This would be 35 because it was 10. Energy change of 5, so call that 20. Are we okay with that? Yep, you're right. That is 5 plus 25. All right. Then, make sure to label the reactants. The reactants are here. The products are here. Okay? And really, technically, it would be the energy of reactants and the energy of products, but you know I'm lazy. The activation energy would be from where you started to the very top of your hill. That's your activation energy. Activated complex, that's the thing at the very top. All right? And when we lit the magnesium on fire, once it was on fire, it was at the activated complex, and it just gave off energy from there. All right, then, with the dashed line, represent what it would look like with a catalyst. So it would start and end the same place-ish, but the bump would be smaller, and the time, because time's on the bottom, it would reach the products quicker. What's that? That's the catalyst. The catalyst lowers the bump, so it makes it reach the end of the reaction faster. Say that again? Yeah, it doesn't have to be technical. The dotted line just has to be lower than the activation energy, and it should go flat sooner than the red line. Okay. The initial concentration of a reactant in a first-order reaction is 0.27 moles per liter. The rate constant is this. What is the concentration of the reactant after 1.5 seconds? So what math equation am I going to use here? It's the integrated rate law for a first-order reaction. I have that table. It's the ln of AT, I believe, equals negative KT plus the ln of A naught. Correct? What is the concentration after a certain time? So we are solving for this value. Will you give that a minute? I don't know the answer. Did anyone else get 0.87? 0.87? Okay. It's okay. What does anyone have what this right piece ended up to be right here? Shh. Shh. Okay, here we go. Hey, please, that's what he said. What post? Okay, look. Please remember, don't talk, Boyd. We get negative 2.4, correct, on the right side? No? We should. We should. Okay, remember, to get rid of ln is the e. So the inverse of ln is e raised to negative 2.4, and I guess that was 0.087. Okay, whatever. I'm going to go with 88 because that was my number when I was a sophomore in high school and I played football. All right. How many could successfully do that problem? Okay. It's just, I know it's algebra, and this is a chemistry class, and I'm not even remotely qualified to teach it, but it's not that bad, right? Okay. The following mechanism is proposed. Write a balanced equation for the overall reaction. Okay, so I haven't had you do this part yet, but it's very simple because we did do it in another chapter. When we write the balanced equation, so we just have to get rid of intermediates, all right, or intermediaries. If it's on one side and the other, I can cancel it out. It's right here. It doesn't matter. I didn't write this, by the way. This is a way the AP test is trying to give you more than 1 point for something that's not that hard. Okay, so you would have H2 plus 2 ICLs goes to I2 plus 2 HCl. You okay with that? Like, we have actually done that, just not in this chapter. Okay, now, do those parts yourselves. Not that that will take very long. Yep. Okay, here we go. And let's make sure we address Brinley's question because she's right there too. All right, so the only intermediate is hydrogen iodide. Typically that's an acid, but this is not in water, so we would call it hydrogen iodide. All right, so the rate was equal to KH only to the first, all right, or H2 to the first because I can't get that high, but whatever, you can see it. Now, ICL was only raised to the first also. And that's because there was not a second ICL in the slow step, right? But as Brinley said, hey, if the first one was fast and the second one was slow, would ICL be a 2? And that would be correct. If the second one was the slow step, because then we would include that, and that. We all right with these? Okay. Bell rings soon, so we'll call that good. Tomorrow, you're all welcome again for that. All right, here we go. Got to make that smaller. Okay, so this is where we are using, what's 7? Because it's not a 7. It's a different number that was cut off. All right, give this a shot. You're finding I changed the concentration. The rate changes by this factor. That will tell me the rate law, and use that to find K. All right, when we doubled, what happened? All right, so let me talk. If you change something and nothing changes, then it's that raised to the 0, which is true. We all right with that? So that would be B is raised to the 0 power. Good enough? All right, that probably wasn't the confusing part here. So from here to here, I multiply it by 4, correct? 3. Okay, what happens from here to here? 9-ish. Okay. So if this was a 3 you said, if you have a 3 become a 9, then A must have been squared, because 3 squared is 9. All right, so rate equals K. This isn't communicating very well. math-wise, I can just eliminate this because it's just going to be a 1, right? So I can say 2.83 equals K times the concentration of A squared. Correct? So just divide this by 0.273 squared. And what did that equal? Okay. We all right with that? Okay, we'll do more tomorrow. Be patient. If you haven't read the book and done this sample exercise as I would, the online textbook will help you as well.